Now we will return on glaciers and in particular on the glacier contribution to sea level rise. To inform us about glacier contribution to sea level rise, we invited Massimo Frezzotti. Massimo. Okay, Massimo, can you hear me? Okay. Yeah. It's your time. So.
Okay, microphone is working.
Yeah. Yes, we can hear you.
The screen is okay?
Yes.
Okay, thank you to invite myself. I will speak mainly, so my colleagues are already introduced glacier and permafrost, so I will concentrate my presentation mainly on ice sheet and polar region and their contribution to sea level rise. So the cryosphere covers more or less 30% of the planet. 50 million of square kilometers of snow change every year. Sea ice cover about 35 million of square kilometers of ocean, and the other huge mass is the ice sheet that is cover about 40 million square kilometers of land. But also permafrost is cover very large part of the northern hemisphere, with cover about 25 million square kilometers, about 16% of the land. And glacier is small, but the only glacier and ice sheet contribute significantly to sea level rise and also permafrost. But this one is the most part where we are few knowledge about the situation. So snow obviously and is linked mainly to the precipitation temperature. Sea ice and ice shelf do not contribute to sea level rise, but is very important for the ice dynamics of the ice sheet. So it's not directly contributor, but it's very important because the ice shelf represent the bottleneck of the ice sheet ice velocity, and the sea ice is very important for albedo. The recent study just published showed that the cryosphere area of our planet have shrunk at the rate of approximately close to 90,000 square kilometers per year. This is mainly on the northern hemisphere and is due mainly to reduction of sea ice on the Arctic here. And this surface represents more or less a third of the surface of Italy. Other colleagues show that since the satellite era, there is a reduction of about 27.4 trillion tons of ice, so there is a decrease significantly. Most of these are on northern hemisphere, 58%, and 42% is from the southern hemisphere. The rate of ice loss has risen by 57 since the 1990s periods, and this loss contributed to a rise of about 35 millimeters of sea level. The majority of ice losses were driven by atmospheric melting, 68%, and the rain losses by ocean melting. This is a graph that shows how in the Arctic the air temperature increased since in the satellite era, so 1979, and we see the reduction of the sea ice extent, and also as a feedback of the sea ice extent reduction, increase of the sea ice surface temperature. This is a very important issue because the sea ice reflects about 90% of solar radiation, and the sea ice surface reflect about only 20%. So the 80% is going in the water and increase the temperature. This is a reconstruction of the Arctic sea ice during the last 15th century. You see signs 500 here, and we are here. You see there is a change, there is a variation, but what we see as a reduction of the sea ice is we do not see any change so drastically so far, and so limited extension of sea ice in Arctic region. In August arrived the information that rain fell at the Greenland summit for the first time on the record. This was an image of 2 years ago that showed a very large melt in Greenland, but this is very new because our summit point that is here is at elevation of 3,200 meters, is at about 73 north of latitude, and is 80 kilometers north of the polar cycle. When the rain fell occurred, the temperature was plus 18 above average temperature. So other melting phenomena has happened in the past, in 1995, 2012, 2019, but never rain. And ice core tell us that these phenomena have never happened, at least during the last 2 centuries. You see here the mass loss in Greenland. This is coming from satellite gravimetry satellite, GRACE 4. You see that there is a reduction, and the reduction is significantly since the 1980s. The mass loss has increased 6-fold since this period, with close to 14 millimeters since in 1972. But the most important, and that we observe an acceleration of about 80 gigaton per decade during the last period. So we observe a significantly, you see that there is a strong decrease in mass in Greenland. For Antarctica, we see the same. We see that there is, and Antarctica contribution to sea level is about 40 millimeter cumulated since in 1979. The mass loss increased from 40 in 1970 in 98 periods up to present at 252. The change most reflect an acceleration of about 48 gigaton per year between the 2 decades. And you see there is a very strong increase of melting, of a reduction of a mass in this area on Amundsen sea area, and also in Totem Glacier area, and also in this is the Antarctic Peninsula. In some other places, like in this part, and this part is due to the capture of a drainage system. This part, the increase, the small increase, is due to the increase of the snowfall in the area. You see here the rate of a thickness variation of the ice shelf in meter, and the temperature of the ocean. It's clear that this reduction that we observe in West Antarctica is linked with intrusion of warm water in Antarctica that arrive at the ground line, the point where the ice sheet starts to floating on as the ice shelf, and the thinning of this part is increased a huge. There is part where the melting reach close to the ground line, the 200 meters per year, and with a strong increase during the last periods. So when we are speaking about global warming, we are thinking at the higher temperature. This is the the air temperature anomaly in atmosphere, and this is on ocean. But we must thinking that the ocean warming dominate the increase in the energy stored in the climate system, accounting for more than 90% of energy accumulated between 1971 2000, with only about 2.3% stored in atmosphere, 2.1 in the land, and 2.3 was used for the melting of the ice. So the sea level is rising at about 3.4 millimeters per year, and this is dominate at the present from the melting of the glacier and the ice sheet, and the 30% for expansion of the seawater, because when the ocean increases the temperature, there is an expansion. So what we observe, the global sea level have rise about 20 centimeters over the last 170 years, a growing rate of 0.0 millimeter per decade. And this rate is unprecedented over the past at least 2000 years. What we know about paleoglaciology, ice and core. So this year we're doubling the CO2 in atmosphere. Now the CO2 in atmosphere is 420 ppm, and at the pre-industrial era, the amount of CO2 in atmosphere was 280. So in more, something less of something more of 1 century, we increase of 140 ppm of CO2 in atmosphere. This concentration was present only during Pliocene 3 million years ago, where Arctic Greenland probably is no ice sheet is present. Part of Antarctica was melting, and the sea level was 20-25 meters higher than present. Ice cores show that during the last 800 years, the 1000 years, the sea level was sometimes higher than present, but never reached the concentration of CO2 of the present. What we observe about the predicted sea level contribution from Antarctic and Greenland sheet, this is what you see here in gray, is what we see as a contribution, and this is the sea level rise projection of the previous IPCC report. You see that the observation of the sea level contribution of Antarctic and Greenland is close to the maximum of the projection, not on median, on average. On the base of the last report, IPCC, the contribution at the end of this century will be between 0.5 to 1 meter of the sea level rise, with if warming will excess 4 degrees. The Greenland will continue to lose mass in all scenarios until this century, and will continue also later, with a contribution of between 90 to 32 millimeters of sea level rise. Antarctic projection leads to threshold spread in median projection of land ice contribution to sea level rise, ranging between 130 to 420 sea level rise. Worst scenario, more consistent with current policy, give an abrupt jump in the pace of Antarctic ice loss after around 2060. Contribution about 5 millimeters per year of sea level rise per year by 200 at the end of the century. This contribution is an order of magnitude faster than today. So one of the points that I would like to stress, that we know on the past that the climate is not linear, so there is a jump in the phase. So This is glacial periods. This is entire glacial periods where we are now, but during the Holocene, but due to the human emission of greenhouse houses, we are now in Anthropocene. And we could jump in outhouse Earth or return on stabilized Earth, depend what will be our decision about the greenhouse. So I would like to stress the climatic type point is too risky to be a gaze. In a cartoon, Willy Coyote often goes through a point of return. That is, it's find that itself crossing the edge of a precipice. Then he continued to walk for a while on nothing until he noticed it and only then fell into a void. So this is important. This is a cartoon, but we could be close to this situation in several points. And you could see what is this growing threat of abrupt and irreversible climate change, and this should be important because as you see, most of this is coming and is related to cryosphere. So the reduction of Greenland, the reduction of Antarctic summer, Arctic winter sea ice, the permafrost, that is very important because there is feedback with a strong emission of greenhouse gases, the Alpine glacier, and West Antarctica and East Antarctica. This is also linked to the other one, so to the change in jet stream, thermoline circulation, El Nino. So I would like to stress that cryosphere is very important for our climate, is one of the drivers, not only for the sea level rise, but also for several other points. So the key message what we would like to go to COP26 is the cryosphere of our planet is shrinking and disappearing with the consequence of the sea level rise that is unprecedented during the last 2,000 years. I fear the consequence this will have on the climate of our planet. Climatic change is taking place and we are responsible for alteration on environment. The sooner we stop greenhouse emission, the more we safeguard of the planet for our children, grandchildren, great-grandchildren, and further generation. Thank you for your attention.